Hello, this is Mr. Wynn, and today's video will be about graphing exponential functions. So, a function like y equals 100 to the x power, where the base is a constant, it's a number, and the exponent is a variable, so x is the exponent now. We call it an exponential function. Now, there's a growth function, exponential growth function, if you have f of x equals b to the x, where b is bigger than 1. Alright, b is new, b, if it's bigger than 1, it's going to be growth, and later you'll see when b is less than 1, it'll be decay. Now, these graphs always have an asymptote. An asymptote is a line that the graph approaches and never crosses. And I'll show you how to find that in a second. But here's basically the graph of a parent function. You see how it's going up, so that's growth. Domain, all real numbers. The range is only y is greater than 0 because it does not cross this asymptote. All right, it'll never go into negative numbers for this picture only. Now it could later on. So that's why the asymptote is the x-axis, or y equals 0. There's an intercept at 0, 1. There's no symmetry, and there's no minimums or maximums. Now the way I want you to approach this is like this. Our format is the same as before. And all the transformation techniques we've done for up, down, left, right, taller, wider, flipped or not, still is the same. So we have a, we have a h and a k. They all do the same thing. So let's start with h. H goes left and right. So it shifts it left to right. K shifts it up or down. By the way, h is opposite, remember that? A is taller or wider. And then if a is negative, it's flipped. All right, flipped or not. Flipped, or I'll say regular. Regular means it's not flipped. Then b is new. B is what we call the growth factor. It tells you if it's, or it's called the rate. It tells you if it grows or decays. It's the rate. Growth or decay. Now we gotta add one thing. K will always be our asymptote. B asymptote. And A will always be our start point. Our start point. Right. Now B is the thing that has the exponent of x. A doesn't have the exponent of x. See, this right here, sometimes they actually write A times b to the x power if there's no h or k. Alright, so a is separate. Alright, so remember, if b is bigger than 1, it's growth. If b is smaller than 1, it's decay. So going back, here they said it's bigger than 1, so it's growth. You see here a is 0, or sorry, a is 1. That's why the start point is 0, 1. And you see how k is 0? Because there's nothing being added or subtracted. That's why the asymptote is y equals 0, or the x-axis. Alright, so example 1, sketch this, tell me if it's growth or decay, also state the domain and range. Well, let's do A, B, H, K. Identify what they are. Alright, remember the form was A times B to the x minus h plus k. Alright, so A is 1/2. That's our start point too. Start, we know it's not taller, it's wider, and it's regular, it's not flipped. Alright, B is that thing that's being raised to exponent, has the exponent x. So B is 5. Well, since B is 5, that's more than 1. That's growth. So I answered one question. H. Now, remember, that means right 2. Alright, now I'm going to start doing this correctly. That is the opposite of H that's being shown. So H is actually positive 2. That's why it says right 2. Because the opposite of H goes next to X. Then K is 1. So that means it's up 1. That's also our asymptote, which will help us figure out the domain and range. So let's graph this. I should start at 1/2. So this is 1. Let's call 1/2 right in the middle of that. But it says go right 2, up 1. So here's 2. 2. So I'm starting at half. I go right 1. Sorry, right 2, and then up 1 right here. This point should be 2 comma 1.5. Alright, so basically I had to add the k to the a. Alright, my asymptote I'm going to draw next. K equals 1. I can never cross that line. I approach that line, so let's put this here. Alright, that's our asymptote. And then it's growth, so it's going up. So I'm going to draw it like this, going up. It approaches this, right? It'll never cross that line. It approaches the line. It gets really close to 1 for y equals 1, but it never becomes 1. This is my picture. Domain. How far left, how far right? It goes left forever, it goes right forever. So negative infinity to positive infinity. Or what we can say is all real numbers. My range, how low does it go? Well, the lowest is 1, because that was our asymptote, and it does not touch 1, so open parentheses. Highest goes is positive infinity. Or we can say y1, it's above 1, so it's greater than 1. And there's every question and answer to that. Alright, decay is the second type of exponential equation, where b is less than 1. It's between 0 and 1. You can have a negative in there. Alright, but same idea. You look at a, b, h, and k. Domain is still all real numbers. Range, so there's still an asymptote. In this case, it's still k. K is 0, so it doesn't cross that. And it still has the same start point, wherever a is. Alright, transform the same way. A, so up, down, left, right, taller, wider, flipped or not. Alright, so same idea. Sketch this. Tell me if it's growth or decay. I'll state the domain and range. So same thing. Let's find what a, b, h, and k are. Well, a is the thing in front that doesn't have an exponent. It's 2. So I know it's my starting point. It is taller. And it's regular. It's not flipped. It's not negative. Alright, b is what has the exponent. Is 1/4. 1/4 is less than 1. So that's going to be decay. H is, oh, I know it's going to go left 2. No, H is more opposite of that. So H is x opposite of H. That's really negative 2. That's why it's left 2. And K is negative 3, meaning it's down 3. That's also our asymptote. Remember, we approach that line, but we never cross that. So sketch this. So 1, 2. I'm going to start at 2, but I have to go left 2. So left 1, 2, and then down 3. So from here, I go left 2, 1, 2, and then down 1, 2, 3. So really, I'm going to start right here. All right. Let's do the asymptote. K is negative 3. So let's do that. So that's negative 1, negative 2, negative 3. Let's draw this asymptote. Or do not cross that line. And its decay means it's going down. So it's going to go up here. It's going down here. But it approaches out, levels out, like it flattens out. There's my picture. And then domain and range. Domain, how far left to go? It goes left forever, negative infinity. How far right to go? Right forever. If you see negative infinity to positive infinity, you say all real numbers. My range, how low does it go? It goes down to negative 3, and it goes up to positive infinity. Or we have y, negative 3. It's above negative 3. All right, so there's that. Now last is sometimes they use this form instead. They use a parentheses 1 plus r plus parentheses c to the t power. That's the same thing as a b to the x. Basically, they're calling x t. They're putting 1 plus r where b is, or maybe they're putting 1 minus r where b is. Because remember, b tells you if it's growth or decay. If it's above 1, it's growth. If it's below 1, it's decay. So you have 1 plus some number r, means the number will be above 1, growth. You have 1 minus some number r, it's less than 1, it'll be decay. Right? This is helpful when we have percentages. So for example, we have a cup of green tea, contains 35 milligrams of caffeine. The average teenager body can eliminate about 12.5% of the caffeine from their system per hour. Let's find the equation. Well, here's where I want to use that, and it's getting rid of it, so it's going to be 1 minus r to the t power. We'll call x, doesn't matter. All right, A is our starting amount. We started with 35 milligrams, and we're losing 12.5%. Change that to decimals, 0.125 to the t power. I'll call it x. So here's my equation. All right, and let's fix the parentheses. So that's really y equals 35 times 0.875 to the x. So you'll see how b is 0.875, which is less than 1. That means it's decay. Now they're asking this question, how much caffeine is left after 3 hours? Well, time is t or x. Just plug in that. So what is y when x is 3? So here's where we just plug in 3 where x is, use a calculator, and we're done. So if it started out with 35, let's see how much is left over. 35 parentheses 0.875 to the third power. There's 23.44 left. 23.44. 4 milligrams left. All right, so after 3 hours, we went down to about 23.5. So we lost, or the team got rid of 11.5 milligrams in 3 hours. Now, the next 3 hours isn't going to do that much. It's going to be less because there's less of it to decay. All right, here's your practice problem. Graph that, sketch it, find domain and range, find me A, B, H, K, things like that. Here's the answer. All right, if you can do that, you should be fine for class. Again, thanks for watching. This is Mr. Wynn. See you later. Bye.